In this video, we will analyze the effect of sleep on mental performance. The problem we're going to look at consists of 100 volunteers that are divided into two equal groups of 50. Each volunteer took a math test that involved transforming strings of 8 digits into a new string of numbers associated with a specific criteria. The difference between the two groups is that one group of 50 volunteers had 8 hours of sleep before taking the test. The other group stayed awake all night. The question we're being asked, from the study, what can you infer about the proportion of volunteers in the two groups who successfully transformed the numbers per this specific criteria? We're asked to support our answer by creating a 90% confidence interval. So the equation we're going to use is we're going to use P1 hat minus P2 hat plus or minus Z alpha over 2, where alpha will be equal to 0.1, and then times this standard error term, as I call it, and it's the square root of the sum of the product, P1 times Q1 over N1, plus P2 times Q2 over N2, where Q1 and Q2 are equal to 1 minus P1 and 1 minus P2 respectively. So the data that we have is that we had, out of 50 students that got the 8 hours of sleep the night before, 39 were able to do this transformation of data. The students that stayed awake all night, only 15 students out of 50 were able to do this transforming strings of 8 numbers into the new string as we've talked about. So the first thing we're going to do is we're going to create or calculate, I should say, the proportion of the students that were able to accomplish the task that slept the night before. It's just equal to x1 over n1. So that is a proportion of 0.78. Doing the likewise calculation on those students that did get sleep is 0.30. Now we're going to calculate the, I'll say the standard deviation component of if you will, of each sample of data here. So we're just going to say square root, or excuse me, we're just going to do equal P1 times 1 minus P1 divided by N1. And we have a number, 00343. And we're going to do the same thing on this side. It's going to be equal to 0.3 times 1 minus 0.3 divided by N2, which is also 50. And we have this component here. The Z alpha over 2 for a 90% confidence interval is 1.6449. Okay, so now we're going to calculate this standard error, which is the square root of the sum of these two terms. So it's going to be equal square root, and then we're going to add this number and this number, and we get this number. Then the margin of error, which is the product of Z alpha over 2 times the standard error, this times this, equals this times this, and this becomes our margin of error. So for a 90% confidence interval, first thing we're going to do is we're going to get the difference of P1 hat minus P2 hat. That's this term right here, and that's simply going to be minus 0.78 minus 0.3, and we have a proportion difference of 0.48. This would be the point estimate, and now we're going to add and subtract the margin of error to each one of these, or to get each one of these bounds. So the lower bound is equal to 0.48 minus 0.144, and the upper bound is the point estimate plus the margin of error. So our confidence interval goes from 0.336 or 0.34 to 0.62. So what we infer is the proportion difference of math scores for this type of test at a 90% level of confidence between students who got 8 hours of sleep versus those students that stayed awake the night before is between 0.34 and 0.62. Okay, so this is what we infer. And let me just state it again for the record. The proportion difference of math test scores for this type of testing at a 90% level of confidence between students who got 8 hours of sleep versus those students that stayed awake the night before is between 0.34 and 0.62. The question is, now, is this statistically significant? And the answer is yes, okay? And the reason it is statistically significant is because this confidence interval does not go through 0, okay? Clearly, P1 is greater than P2, and that bound, that lower to upper bound for the proportion difference is between 0.34 and 0.62. That concludes this video.